Okay, so I'm going to do another short example here of conditional probability. So I'm rolling a die and I have the two events. The die landed on a 1, 2, 3, or a 4. And B is the event that landed on a 2, 4, or a 6. And I want to find the probability of A given B. That means the probability that A happened, knowing that B did happen. Okay, so for this one, I'm going to do a Venn diagram just to have, I'm going to do it two ways, sorry. First, I'm going to do it directly without the multiplication rule, and then I'm going to use it using the formula for the multiplication rule. So I'm going to do a Venn diagram here saying, well, my universe or my sample space has all numbers 1, 2, 3, 4, 5, 6. I'm going to try to put them in a smart way. A has the 1, 2, 3, and 4 on it, so I'm going to put a 1, 2, 3, 4. B has the sets, the numbers 2, 4, and 6. So I'm going to put the 6 somewhere here. And I think I'm going to move the 4 somewhere here so I can see it like that. Okay. I left the 5 out, so the 5 is somewhere there. So those are all my numbers in my sample space. So I'm going to put with red my A. So A is 1, 2, 3, 4, and 6. So this is my event A. Right? 1, 2, 3, 4, and 6. Sorry, 1, 2, 3, and 4, not the 6. Okay. 1, 2, 3, and 4. Yeah. And B is the event 2, 4, and 6. So let me grab another color for B. So I'm going to grab blue for B. And B is the 2, 4, 6. So I can visually see now that the probability of A given that B happened is, what's the probability that it landed on a 2 or a 4, right? Those are the ones that are in A. If I know that it landed on a 2, 4, or a 6, right? Because that's what B was. So the probability of this is going to be 2/3. Why 2/3? Because I'm only considering those that happen in B, right? I know that B happened, so I only have to look at these. Oops, sorry. I only have to look at these. So now knowing that it landed on that B happened, what is the probability that A happened? So A is the red circle, and there's 2 in that part of the red circle, right? So it's 2/3. So that's using the understanding. Sometimes we can just do this. Now I think I have this is the part of when we saw what the multiplication rule was for this. So the formula for the probability of F given E is the probability of E and F divided by the probability of E. So in this case I have E of F's and now I have A and B. So let's just rewrite it in terms of A and B. So I have the probability of, I want to find A given B. So it would be the probability of the and, so A and B. That doesn't change, right? A and B is the same as B and A, so it doesn't matter. Now remember the denominator is this part. So here's going to be divided by the probability of B. Okay. Now when you consider these on the right side, you have to consider them as from the total sample space. Okay, that's something you have to remember when you implement the formula. You're thinking of the events. What is the probability that A and B happened? Knowing nothing at all, just you roll a die, and so you have to find what's the probability that A and B happen. So what is A and B? A and B is, well, A and B is these two numbers, right? Those are the two that are in both A and B. This is in sets. That's why I like to write it like this. This is the intersection of the set A and the set B. So I can write the intersection of the sets A and B. So those that are in A and B at the same time, there are 2 of them. So it's either 2 or 4 out of 6. So that numerator would be 2 over 6. And the denominator is, what's the probability that B happened? Well, B is the blue circle, the what's in the blue. So it's 3 out of 6, right? So these are considered from the total. So if you do this formula again, this depends on how you used to do it with fractions. The denominator comes up flipped over by the reciprocal, so those 6's are going to not show up. They turn out to be a 1, so it's 2/3. So doing it this way, of course, I get the same thing again. Yeah. So I just want to be clear that I did a couple examples where you can use it both ways. Sometimes you can't. Sometimes they give you the information only about the E given F part, and they ask you to find what's the probability of E and F, or they give you the information about the E and F and in the probability of E, and you're asked to find the probability of F given E. But you can not always do it both ways like I did.